Hello everyone, welcome to prevent a solution given this nice algebra problem, which is x times x times x plus x is equal to 30. So what is the value of x? Now solution here, x times x times x, this is x to the power 3, plus x, this is equal to 30. So now from here, let's take 30 on the left hand side. We'll have x to the power 3 plus x subtract 30, this is equal to 0. Now here we'll have x to the power 3 plus x subtract 30, which we can express as 27 plus 3. This is equal to 0. Now the next step here, we'll have x to the power 3 plus x subtract 27, which you can express as 3 to the power 3, subtract 3. This is equal to 0. Now we can see that the exponent here, let's combine x to the power 3 and 3 to the power 3. We'll have x to the power 3 subtract 3 to the power 3 plus x subtract 3. This is equal to 0. The next step here, you find that this particular part here, x cubed minus 3 cubed, this is the difference of 2 cubes expressed as a cubed minus b cubed, which we can express as a minus b, a squared plus ab plus b squared. So the next phase here, that's x cubed minus 3 cubed. This is the same thing as x minus 3, x squared plus 3x plus 3 squared, which is equal to 9. So let's substitute this back to the equation. Let's substitute this back to the equation so that we'll have x subtract 3, x squared plus 3x plus 9 plus x minus 3. This is equal to 0. So x minus 3 here is common. So let's factor out x minus 3. So that now we'll have x subtract 3, okay, into the parentheses. This is x squared plus 3x plus 9 plus 1. This is equal to 0. Now, the next phase here is that we have two parts here. The first part is x minus 3. This is equal to 0. And the second part is a quadratic equation, which is x squared plus 3x plus 10. This is equal to 0. Now, from the first part here, x1 is equal to 3. So the next part is a quadratic equation, which is basically in the form of ax squared plus bx plus c. This is equal to 0. So from the quadratic equation, a is equal to 1, b is equal to 3, and c is equal to 10. Now, let's assess the nature of the root of this quadratic equation by determining the discriminant value, which is actually b squared minus 4ac. Okay, so b squared here, this is 3 squared, subtract 4 times 1 times c, which is 10. So this is 9 minus 4 times 10, this is 40. So here it's 9 minus 40, and this is negative 31, which is less than 0. So this means that we have two complex roots here. We have two complex roots. Okay, and let's solve for these two complex roots by introducing the quadratic formula. That is x2 and x3. This is negative b plus or minus the square root of b squared minus 4ac, all this divided by 2a. Now let's substitute the values of a, b, and c. Now we have negative 3 plus or minus b squared minus 4ac, which is essentially, this is equal to negative 31. So we'll have negative 31 divided by 2. So here we'll have negative 3 plus or minus. Now we can express square root of negative 31 as 31 times negative 1, all this divided by 2. And this is actually going to give us negative 3 plus or minus I, the square root of negative 1 is I, square root of 31, all this divided by 2. So that means that we have three solutions. We have a real solution, that is x1, which is equal to 3, and that we have x2, which is basically equal to negative 3, plus I, square root of 31, divided by 2, and we have x3, which is negative 3, subtract I, square root of 31, divided by 2. Now, the next step here, let's verify that this x1 actually satisfies the equation. So we have that x times x times x plus x, this should give us a value of 30. So substituting the value of x here, this is the same thing as 3 times 3 times 3 plus 3. This should give us a value of 30. So 3 times 3 times 3, this is 27, plus 3, this should give us a value of 30. So here, 27 plus 3, this is 30, which is equal to 30. So here, that means that the left-hand side is equal to the right-hand side. And that affirms that the value of x1, which is 3, actually satisfies the equation. This is only the real solution here. x2 and x3, these are complex solutions. So kindly follow the steps, like this video, and subscribe. So see you in the next video. Bye bye.